Hi. Um, to complete section 7.3, I want to describe the um, normal distribution that we can use to approximate a binomial probability distribution. So if you remember, earlier in previous chapters, we talked about the binomial probability distributions. And the binomial distributions are probability distributions that they have a fixed number of trials. Each trials are independent from each other, and each trial are classified into two categories of success or failure, and the probability of trials stay the same in all trials. And if you remember, when the binomial distribution is a type of discrete probability distribution, and discrete means only you find the probability for some specific numbers, not for all values. And if we were supposed to find, for example, the probability of when x was less than or equal to 5, so all of the numbers that are less than 5, less than or equal to 5 are 5, 4, 3, 2, 1, and 0. And we were supposed to find all of these probability and then add them together if we want to find the probability when x is less than or equal to 5. And for each of these probabilities, we were supposed to use that big formula that we learned in that chapter for the binomial distribution for all of them. And you can imagine how time consuming it is this, especially if we have bigger number. For example, they ask us to find the probability when x is less than or equal to 20. So you have to do this process about 20 times, which is kind of impossible if we want to do it manually. Now, learning about the normal distribution helps us because we can use a normal distribution, which is easy to find the probability because in any normal distribution, the probability is just the area under the curve. So we can use a normal distribution to approximate a binomial distribution. So what should we have to do? So to do that, first of all, we need to check the requirement. If you see we have a binomial probability distribution problem, and we want to use normal distribution instead, first we check the requirement if we can do that or not. So what are the requirements? First, the sample must be a simple random sample. Second, n times p and n times q both must be greater than or equal to 5. And if you remember, n is the number of trials. P is the probability of success. And q is the probability of failure, which is 1 minus p. So we multiply n by p and n by q. If both of them gives me a number more than 5, so it tells me that yes, I can use a normal distribution to approximate the binomial distribution. But for every normal distribution, if you want to use any normal distribution, we need two things, mean and the standard deviation. So we need to find the mean and the standard deviation first. How do we find the mean and the standard deviation? The exact formula that we had in that chapter for finding the mean and the standard deviation of the binomial distribution. And the mean, mean is n times p, and the standard deviation is the square root of n times p times q. After finding the mean and the standard deviation, now everything is ready, because when we have the mean and the standard deviation, we can convert the x to z by using the formula that we had. And then when we have the z, we can look at the z table, find the area under the curve, and we are done. But we know that area under the curve means that we have to have intervals. If you want to find the area under the curve, you cannot find the area on a some specific points, because we know the area, the probability when x is equal to a number in a normal distribution is always 0. And the binomial distribution is also a discrete probability distribution. So what should we have to do that? To fix that problem, we need to do the continuity correction. Okay, so the continuity correction helps me that instead of having the probability on a specific point, have an area that and have an interval, and finding the area of that interval, it's easy by just looking at the areas on the left or right and just looking at the z table. Okay, so how does the continuity correction work? For example, when they ask me find the probability when x is equal to 3, because it happens when we have a binomial distribution, but not in a normal distribution. If we have binomial distribution and they ask us to find the probability when x is equal to 3, so you know that in binomial distribution, we always have a bar above each number. But in normal distribution, we have curves. We have a curve and we find the area under the curve. So what do we do in this case? To find the area, or to find the probability when x is equal to 3, that means you want to find the area of this bar. And this bar means starting from this point to this point. You need these 2 points and find the area from first point to second point. And you know that the length of each bar in a binomial distribution is 1, which means that the beginning and the end of each bar is just 0.5 away from that point. That it means that this bar starts at 2.5 and it ends at 3.5. So instead of finding the probability when x is equal to 3, I want to find the area when x is between 2.5 and 3.5. Now I have an interval, and it's possible for me to find the area under the curve for that specific interval. Okay, so always we need adding 5 or subtracting by 5. It depends what area we're trying to find. Area to the left or area to the right. And after doing a continuity correction and find the interval, now you have the area, you have the interval, you can easily convert the x to z and then looking at the z table and find the area under the curve. And you are done. And that makes it so much easier to use a normal distribution because it's just the area under the curve instead of using that formula in the binomial distribution many times. Let's look at some example. Let's see how the continuity correction works first. Use a continuity correction to convert each binomial probability to a normal distribution probability. The probability of getting between 270 and 310 successes inclusive. Okay, if you want to use binomial distribution properties from 270 to 310, inclusive means both of them are included as well. You need to find the probability for 270, 271, 272, 273, all the way to 310, which is about 40 numbers. If you want to use the binomial probability, you need to use that formula 40 times and then add them together. But we want to use normal distribution instead. We want to find the area under the curve between 270 and 310. But how do we know which point do we have to use for the continuity correction? If this is a normal distribution, if 270 is here, it's in a, if this is 270, we always have a bar above each number in a binomial distribution. And if 310 is over here, and we have a bar here as well. When you want to find the probability between these two values, If it was only between 270 and 310, that means you were supposed to find this, start the area from this point to this point. But when it says inclusive, that means you want to include these numbers as well. So you want to include the bars as well. It means that your starting point is this point, and the end point of the interval is this point. And the starting point is 0.5 before 270, and the ending point is 0.5 after 310. It means that I need to find the probability when x is between 269.5 to 310.5. 0.5 before 270, 0.5 after 310. And now finding this area is easy because you convert both of these x values to z, and then looking at the z table to find the area under the curve for both of them, and then subtract from each other. Let's look at another example. We want to find the probability of getting at least 158 successes. At least 158 means 158 or more. So it means x must be greater than or equal to 158. This is the probability that you want to find in a binomial distribution. And it depends depends on the number of trials. You need to find all of those probabilities from 158 to the maximum number of trials that we have. But if I want to use the normal distribution, I know that I need the area under the curve. Okay, so always create a normal distribution, a bell-shaped curve, and show 158 somewhere inside the bar. That's 158 in the middle of the bar. Now, since you want to find the area when x is greater than or equal to 158, greater than means the area to the right. Equal sign means include the bar as well, which it means you want to start from this point and you want to find the probability when x is greater than, this point is 157.5 because it's 0.5 before 158. Now you have an interval, you can find the probability for in the convert it to z and find the area from the z table. Okay, now based on all this information, we want to work on the problem. We want to follow all the steps now. It says, in a survey of high schools in a certain state, it was reported that 40% of students failed at least one class taken through distance learning. So when you read the question, you can see that it's kind of definition of binomial distribution, because it says you randomly select 45 students, so the number of trials is fixed, is 45, and the probability of success for each trial is the same, which is 40%, so the p is 40%, and the trials are independent from each other because the students are independent, failing or not failing is completely independent from each other. So everything in this problem is defining a binomial distribution. Okay, so right now, you know that the number of trials n is 45. The probability of success is 0.40. And q is 1 minus p, which is 0.60. Now it says, what is the probability that fewer than 20 of them say yes? Fewer than 20 means less than 20. You want to find the probability when x is less than 20. If I want to use the binomial distribution properties, I need to find the probability for all of the x's starting from 0 to 19 and add them together. Probability of 0, 1, 2, 3, all the way to 19, and then add them together. That means I need to use that formula 20 times. But let's see how the normal distribution can help us. So if you want to use a normal distribution, you need to check the requirement first. And the requirement says the sample must be random sample. Yes, it mentioned that the sample is random. And the second requirement is that n times p and n times q both must be greater than or equal to 5. Well, we need to check that. We need to multiply 45 by 0.4. What is 45 times 0.4? 45 times 0.4. Let me see if I have the answer. Okay. It's 18. Yeah, it's more than 5. And we also need to multiply 45 by 0.6, which is 27. It still is more than 5. So yes, it satisfies both of the requirements. It means I can use a normal distribution. Now after that, we need to find the mean and the standard deviation. How do we find the mean and the standard deviation? The formula that we had in the binomial distribution, mean is always n times p, which is 45 times 0.4, and it's 18. Sigma, or the standard deviation, is the square root of n times p times q, which is the square root of 45 times 0.4 times 0.6, and then multiply and then take the square root and gives you 3.29. And after finding these two values, now it's time to do the continuity correction. Continuity correction is for this part. So we want to find the probability when x is less than 20. Let's see how the continuity correction. Less than 20 means if I have a normal distribution and the 20 is inside a bar somewhere, like this one, when you want to find the probability x is less than 20, means you want to find the area to the left. Do I have to include the bar? No, because we don't have an equal sign. It's just less than. So that means your area is up to this point. And this point is 0.5 before 20. And 0.5 before 20 is 19.5. So you need to find the probability when x is less than 19.5. And this is your x value. This is your exact x value. So please pay attention. Don't change the 20 to z value. Change 19.5 to z value. Okay? And after finding the 19.5 as your x value, because of the continuity correction, now you need to convert it to z. And if you convert it to z by having the mean and the standard deviation, you get 0.46. So it means that you need to find the probability when z is less than 0.46. So we need to look at the z table, find 0.46, and see what area is given to us from the table, or using online calculator to see what probability do we get. And any number that we get from table, that's our exact answer, because the question asking us about the probability when z is less than, and the numbers on the table also are and the area to the left, so everything is fine. We don't need to change that number. So we find this value from the table or from the calculators. And that is my final answer. And the probability that fewer than 20 students respond yes is approximately 0.6772 or 67.72%. Let's look at next example. It says 4 friends decided to carpool together to get to school. Each day, the driver would be chosen by randomly selecting one of the 4 names. They carpool to school for 96 days and use a normal approximation to the binomial to calculate the following probability. Okay. Okay, so if it's a binomial distribution, we need to know the n, p, and q. What is n? What's the number of trials? It says use the normal approximation to the binomial, calculate the probability that Janice is the driver at most 20 days. So that means the number of trials are the number of days. How many days do we have here? 96 days. So n is 96. What is p? What's the probability? The probability of selecting any of those friends to carpool others, since there are 4 friends, the probability of choosing each of them is 1/4, which is 0.25. So if P is 0.25, Q is 0.70, because Q is always 1 minus P. Okay, now we want to find the probability that Janice is the driver at most 20 days. So don't forget to check the requirement, which is n times p and n times q both must be more than 5, which I believe it is in this question. Then find the mean and the standard deviation. Mean is always n times p, and standard deviation is the square root of n times p times q. Then when you start working on the problem, when you want to find the probability when x is at most 20 days, at most means less than or equal to 20. Because at most means maximum 20 or less, which is less than or equal to 20. Now, if I want to do the continuity correction, if I have a normal distribution, 20 is inside a bar based on being in a binomial distribution. Less than 20 is this area, but since we have equal sign, we say less than or equal to, we include the bar as well. So that is my last point for the interval. So the interval, and this point is 0.5 after 20, which is 20.5. So I need to find the probability when x is less than 20.5. Now this number is my x value. I need to convert this one to z using the mean and the standard deviation that I already found, and then looking at the z table to find the area on the left. For part B, it says find the probability that Roberta is the driver more than 16 days. More than 16 days means when the probability x is more than or greater than 16. So when we have a normal distribution, if 16 is inside the bar, more than 16 means the area to the right. Do I have to include the bar? No, because there is no equal sign. So it means that the interval for continuity correction starts at this point, which is 0.5 after 16, and is 16.5. So I want to find the probability when x is greater than 16.5. Now this is my x value. So I need to convert this value to z. Okay, and you have the mean and the standard deviation. You already found them here. After finding that z, you need to look at the z table to find the area. But remember, if you're using online calculator, you get the exact answer. But if you are using z table, remember that the z table always gives you the area to the left. But right now you want the area to the right, which it means any number that you get, it must be any number that you get from table, the z table must be subtracted from 1. And for part C, it says find the probability that Barbara derives exactly 24 of those 96 days. We want to find the probability when x is exactly equal to 24. Okay, so if I have a normal distribution, if 24 is inside the bar, if it was a continuous probability distribution, just a normal distribution, the area when x is equal to a number is always 0. But since this is a binomial is a type of discrete, we can find a probability for that, but we need to change it to an interval by the continuity correction. So the interval for exactly 24 is just this bar, from this point to this point, from 0.5 before 24 to 0.5 after 24, which it means I need to find the probability when x is between 23.5 to 24.5. And now this time I need to convert both of these values to z. So I need to convert 23.5 by the mean and the standard deviation that I found, and convert 24.5. And then looking at the z table, find the area under the curve for both of them, And after finding the values, those values must be subtracted from. So I don't have the exact number here, but you can find. And the last question, which is only give you the continuity correction as a hint, and you can finish that. Is suppose in a local kindergarten through 12th grade school district, 53% of the population favor a charter school for grades K through 5. A simple random sample of 300 is surveyed. Okay. So far, when I read the question, I noticed that's a binomial distribution because we have fixed number of trials. The probability of success is the same for all trials because they all have 50% chance. Which is 0.53. And if P is 0.53, that means Q is 0.40. We need to check. If you want to use normal distribution, don't forget to check the requirement. Requirement means n times P and n times Q both must be greater than or equal to 5. Multiply 300 by 0.53. Is it more than 5? Yes. Multiply 30, sorry, not 3. 30 by 0.47. Is it more than 5? Yes. Now, it's N300. Oh my God. Yeah, multiply 300 by 0.53 and multiply 300 by 0.47. If both of them are more than 5, it means yes, you check the requirement. Now, we need to find the mean and the standard deviation. Mean is always n times p, which is 300 times 0.53. And if I want to find it, 300 times 0.53 is 159. And the sigma is the square root of n times p times q. Okay. 300 times 0.53 times 0.47. And the answer is 8.6. After finding the mean and the standard deviation, now we read each part, find the probability, do the continuity correction, and then change it to Z and find the area under the curve. For part A, this part is fixed for all of the parts, but the rest of the problem is different based on what the question is. For part A, it says find a probability that at least 150 favor. At least means minimum 150. That means 150 or more. Okay. To do the continuity correction, always grab a picture for yourself, a normal distribution with 150 inside the bar, and say, okay, if it's greater than or equal to, means include the bar as well, my area starts at this point, not at 150. The area starts at 0.5 before 150, which is 149.5. Now convert this to Z by using the formula. The mean is 159 and the standard deviation is 8.64. And after finding that value, looking at the Z table, I find the area under the curve. Part B, find the probability that at most 160, at most means maximum, means less than or equal to 160. So less than or equal to 160 means if 160 is inside a bar, less than or equal to means this area, and I have to include the bar as well. So the total area means must be from the very left side to 160.5. At that point is 0.5 after 160. Now you convert this point to Z and find the area from the table. Part C, it says find the probability that more than 155. More than 155 means greater than. Greater than 155, pay attention. This time we don't have the equal sign. So it means if in 155 is over here inside the bar, greater than means only the area to the right. Don't include the bar. So you have to start from this point, which is 0.5 after 155. So you want to find the problem when x is more than 155.5. So your x value is this number to convert it to z. Part D, find the probability that fewer than once, fewer means less than 147. Okay, so less than 147 means if 147 is over here inside the bar, less than means just the area to the left, but not including the bar because there is no equal sign. So that's your point. 0.5 E for 147, which means you want to find a problem when x is less than 146.5. And when it says exactly 175 means 0.5 before and 0.5 after that. So instead of x equal 175, you want to find the probability when x is between 174.5 to 175. And both of these numbers must be converted to z, and looking at the z table to find the area. I hope that helps.